Hello everyone. For this tutorial video, I like to explain how friction and other non-conservative forces affect an oscillating system and cause it to vibrate slower and slower and eventually stop. If we remember from previous examples that the work from friction converts mechanical energy into thermal energy, this is exactly as true for oscillating systems. So we can state that the work done by friction is exactly the change in all mechanical energy, so kinetic plus potential. So if we are given a specific problem to solve, such as this spring, we first plug in the formula for friction, identify the appropriate variables that we would use to solve the problem, enter in all of the variables, and conclude that this is our final answer for the force of friction. However, if we wanted to get involved with energies, the answer would become a lot more messy in terms of the formulas. So we can state that the force of friction is exactly equal to the kinetic energy of the spring. So we plug in the longhand formulas for Hooke's law and friction. And now we can see that the displacement is both sides divided by the rigidity of the system. We next remember we derived explicitly the potential energy of a spring. So now we simply plug in all the longhand equations for kinetic and potential energy. And next, make this equal to negative force of friction, because the force of friction always removes or dissipates energy. So we conclude that the exact displacement is rearranging this formula. And we plug in every value we know, and we conclude the exact displacement is 1.59 meters. Although using the formulas for energy, the problem becomes more complicated, we get the same results than if we just asked about forces without investigating energy. But this should make sense because we specifically related energy to what we already know is true about forces. So because we're analyzing the same problem, we should get the same answers for all the variables. In my next tutorial video, I like to talk about resonance, which is the final technical concept related to all oscillating systems. So I will talk about what waves are in general, such as water waves, after that. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.